Am I audible? Okay, so let's get started. So in the past few sessions, we just started with our Excel-based heat load analysis itself, isn't it? With the help of an Excel sheet and by respectively by doing some kind of analysis right on your AutoCAD drawings or CAD drawings, or in other words, shop drawings, isn't it? So from the shop drawings, we deduced the values, especially the areas of wall, glass, and significantly the client data, especially what are the concerns provided by the clients. So these are the things that we've been studied or toned on in the last few sessions, isn't it? So let us just continue on to that topic itself. So yesterday we just completed our calculation regarding this, isn't it? You can see right here itself. We done our calculation till the sensible load, isn't it? So among the sensible load, we completed the wall and glass loads, and respectively the partition walls and all glass factor, roof load, fresh air, and then the equipment loads, lighting loads, isn't it? So that's what we mantled up in the last session, isn't it? Then on the other cards, you can see right here itself. The next step, it should be the room latent heat. So in this step, technically in latent heat loads, we'll be having two different steps, isn't it? Which is meant to be the, 1 second, I will take out the, for latent heat loads, you'll be only having two steps, which has to be the fresh air load and occupant load, isn't it? You can see right here itself on the latent heat loads. The first equation is, it's for the latent heat gain from fresh air bypass. So in here, actually, we need to find out the amount of latent heat present right inside the escaping air. I told you the concept of bypass factor just implies that the amount of air which will not getting contacted with the evaporator coil, or the escaping air is termed as to be the bypass factor. So on the step, we are actually finding out the latent load right inside the bypassed air. Okay, now, so that's what is the equation right here itself. So as per the equation, this cell which is meant to be the FACFM, and this is meant to be the delta HR. Okay, or in other words, outside humidity ratio minus inside humidity ratio. Then later, bypass factor into 0.68. So that's what they mentioned right here itself. But you can see, I told you yesterday itself, it's actually an alphabet which is meant to be a small letter X. So you need to enter the values manually, especially the bypass factor and this 0.68 value. Okay. Then later it's about the latent heat per persons multiplied by number of persons, which is meant to be the occupant's latent load, isn't it? So for that one, again, 36 into 270. So 270, which means, from the page number 31, you can take out the value. For example, actually, this is a restaurant, isn't it? For restaurant, the latent heat per person should be around like 270 BTU per hour for 75 degree Fahrenheit. Okay. So that's what we done right here itself. After that, just add up this both values. Then you will be getting the effective room latent subtotal value. Then now it's about the factor of safety, especially in the case of lateral loads. The factor of safety should be considered around like 5%, which means here, the concentration of lateral load should be comparatively lesser than that of sensible loads, isn't it? That's why. After reducing the value of this factor of safety, then later just add up the subtotal, and the factor of safety will give you the total lateral load. So we studied, especially in the case of this equation, you can see right here itself now, ESHF, which is meant to be effective sensible heat factor. So for this equation, on the denominator side, we need ERSHL plus ERLHL, isn't it? or that means effective room sensible heat load plus effective room latent heat load, which is the summation of both sensible and latent. So, and in this step, actually, they already entered those values, which means simply they summated these total sensible load and total lateral load. So that's what they mentioned right here itself. All right. So after the step, once you completed the sensible load and lateral loads, the other important step is fresh air enthalpy load. So on this equation, here you can see the formula for this one, FACFM into 1 minus bypass factor into delta H into 4.45, isn't it? So in here, 1 minus bypass factor, which means now it's not about the escaping air, isn't it? Here we need to take out the contact factor or the air which will be getting contacted with the evaporator coil. So that's what is meant by 1 minus bypass factor. Clear? That means the remaining 85%. Clear? So once again, the equation FACFM into delta H, that means outside enthalpy minus inside enthalpy. Later, 0.85, which is 1 minus bypass factor into 4.45 or 4.5 roundly. So which will give you around some kind of value right here itself. And after that, add up the whole steps, especially sensible load and the latent load and the total enthalpy load. So you will be getting around like 1 lakh something value right here itself. Then at last step, we need to consider an overall factor of safety of 5%. Then add up the both values. You will end up with a grand total heat load. So in here, the grand total heat load value is around like 1,06,287 BTU per hour. Okay, clear? So now we got the total heat occurred right inside the room, isn't it? So it's very simple to calculate, which means to convert the value into tonnage by how? Just select this cell and divide it by 12,000. Why? Because we know that it has to be 1 ton is equivalent to 12,000 BTU per hour, isn't it? That's it. That means around like 8.9. Now it's about the ERSHF factor. Okay. So now it's time about the ERSHF factor. So once again, guys. So for ERSHF factor, you know the equation, isn't it? Effective room sensible heat load divided by effective room sensible heat load plus effective room latent heat load, isn't it? So effective room sensible heat load, which means this one, isn't it? Divided by effective room sensible heat load plus effective room latent heat load. So that's I told you, they already summated this both values and the value is right here itself. So you'll be getting the value around like 0.80, isn't it? So once you got that value, now I'm going to take out the ADP values. Okay, that means respective for those ESF factor, we need to find out or we need to reduce the ADP value, isn't it? So 73.4, which means around like 72, we can consider. Then 50% RH, okay, 50% RH. What is the ESF factor that we got? 0.80. So yeah, I can nearly take 0.81, isn't it? So the selected ADP is 48 degree Fahrenheit and the indicated ADP is 0.77, which is the lesser value. Okay. So that's how we are generally considering to. So here it should be 46 and 48 right here itself. Then you can see right here itself. Yeah. So here onto this equation, it is nothing but the DCFM, ERSHL divided by 1 minus bypass factor into DBT inside minus ADP into 1.08. So that's what they done right here itself. ERSHL, which is meant to be this value, then divided by 1 minus bypass factor, isn't it? 1 minus bypass factor, which is 0.85. You know this one. Then here they considered the max value of the ADP, which means you can see 46 and 48 is there. So we will consider the max value, which is the 48, isn't it? So 48 minus DBT inside, which is meant to be the 73.4 or sorry, 73.4 minus the max value of this ADP. So that will give you exactly something like 2004-310 CFM. We studied that, especially for centralized machines, 1 ton is equivalent to 400 CFM. That means for 1 ton capacity machine, the machine or the fan right alongside the evaporated coil can provide a 400 CFM of air, isn't it? So typically, we can convert this value by dividing it by 400. Which means 1 ton equal to 400 CFM. Which means 2,430 CFM divided by 400 CFM, which will give you 6 ton, isn't it? How much, guys? 6 ton of machine is actual requirement. Here you can see, as per the total heat load calculation, we got the value around like 8.9, which is around like 9 ton machine is required. But with respective to this dehumidified CFM, you can see right here itself, the value is different, isn't it? Second. So in dehumidified CFM, actually, respective to this DCFM, the actual tonnage required for that area is only 6 ton. That means we don't want to do it as to be an oversized mission, or we don't want to intend to implement a oversized mission right on the project itself. But the problem is not the 6 ton or this neither 8.10. We need to must check whether our company having the existing, pardon, the required tonnage. For example, this is a certain machine lineup right here itself. These are the model numbers and these are the capacity. So for 6 ton capacity, can I choose 5.5 ton? No, it should be less sized. Why? Because we are already considering the DCFM value. So with respect to this DCFM value, the actual tonnage is 6 ton. So we can't take it as to be a lesser tonnage rather than this. So in other words, we can go with this 8.3 ton, isn't it? 8.3 ton, which means it simply compensates this value, isn't it? So the only available spec after 6 ton, pardon, after 5.5 ton is 8.3 ton mission, isn't it? So that's it. So we will be choosing a mission, especially of 8.3 ton mission. And after that, you know, later we need to find out the CFM, isn't it? We know that 1 ton is equal to 400 CFM, which means 8.3 ton into 400, which will give you 3,320 CFM. Okay, then this step you can see right here itself now. That is CFM per square feet. Generally, CFM per square feet should very important while doing the ducting side. Why? Because we need to find out the exact CFM of each areas. So at this time, actually, we need the CFM per square feet value. So how to find out the CFM per square feet value? The total CFM divided by the total area. That's it. That's what the value of the CFM per square feet, which means we need to provide approximately 2.73 CFM in per square feet right inside the area itself. Clear, guys? So this is the concept of doing a heat load analysis using this Excel sheet. All right. So at the end of the heat load, pardon, at the end of this sheet, we can simply provide some kind of text like this. Equipment to be selected, 8.3 ton mission of 3,320 CFM, right on the area. Clear? Is it clear, guys? Hello? Okay. Okay, guys. So is the Excel based heat load analysis is clear? If it's so, we can jump on to the next session. That's where I'm seeking your small consent. That's it. All good? Okay,
Yes,
എല്ലാവർക്കും
sir.
മനസ്സിലായോ? Okay, fine. Avinash and Shanmuga Selvan. All good. Jishwan, okay, le. Okay. Yeah, fine. So here the concept is very simple, guys. It's the Excel based heat load analysis is bit much similar to some kind of data entry process. That means from the AutoCAD drawing, the required values should be entered right inside the respective cells. That's it. That's and with the help of this Excel sheet, you can actually uh, find out the actual tonnage and CFM required for that area itself. Which one I need to brief here? Tell me. I will go on through that one itself. Okay, I will start from the beginning itself. Clear? So initially, if you got a drawing, okay, if you got a drawing, initially you must need to check the units, which means using units command, you need to check the units of the drawing, which is inserted right inside the workspace. Then read the entire drawing and the other data provided by the client. Then let's start with the Excel sheet right here itself. Initially, provide the design conditions, which is meant to be the psychrometric data from the data books. The conditions according to the locations. You need to enter the dry bulb temperature, wet bulb temperature, relative humidity factor. Then, with the help of a psychrometric calculator, you can reduce the enthalpy and humidity ratio. So, correspondingly, you need to do the same for the inside condition also. Later, it's about the area. In order to find out the area, you can either use a polyline command or an area command. So that's what I explained in the last session, isn't it? Then importantly, you need to enter the BOS value, BOFC value from those drawings itself. Later, it's about the FA-CFM step, which is meant to be the CFM per person method and ACPH method. So among these steps, which should be the greater value that you will be considering as your fresh air quantity or fresh air CFM for that calculation right there itself. Next, from this drawing, we need to get a proper idea about the orientation and other kind of aspects. For example, in this drawing, we having northwestern wall. Pardon, in northwestern side, you'll be having exposed wall. Southern side, you'll be having exposed walls and also eastern. But in the northeastern side, you'll be having exposed glass. Okay. So take out the value, take out the length of this each walls and windows with the help of these basic commands, such as dim linear, dimension command, dimension align, dimension arc. Then multiplying those values with the BOS will give you the area of wall, and maybe it is a full height glass. You can do the same for the glass also by multiplying it with BOS. Once you got that value, just check the equation. According to the equation, you need to check the cells are correct or not. At the, pardon, for all glass factor, you need to summate the entire step. Even though there is no values, just do the same. Why? Because, in future, you need to add some more extra right inside the glass area. You don't need to supposed to change the all glass factor area right inside the cell. Instead of that, once you enter the value right in between them, it should be automatically updated right inside the all glass factor cell, especially on the area cell. Okay, later take out the partition wall lengths and multiply those values with the BOS will give you the partition wall area, and respectively take out the roof area and similarly the pressure steps. So just follow the equations. You can simply analyze right in the Excel sheet. Then typically enter the values that you will be requiring by using your data books and CAD drawings. Later, it's about the latent load. So we only having two steps for latent load. Then once you enter these values, it will automatically update the other equations right inside the Excel sheet itself, especially the 5% and the other summations. It should be all done by the Excel sheet itself. You need to simply select the respective factors that you need to include in your calculation. Then at the first step, beg your pardon, once you find out the grand total heat load, you will be getting a round up tonnage. But in order to finalize the tonnage, you must need to do the, or you must need to find out the DCFM value. So with respective to the DCFM value, you will be getting an actual tonnage or the right amount of tonnage or capacity required for that area. Then you might need to check whether the machine is available on with the company. If it's so, you can take out the direct value. Or if it is not, you need to go with a higher capacity machines, which means the nearest capacity machines, not less than, but greater than. All right. Then with respective to that machine, you need to conclude the actual CFM, which should be provided by the individual machine. Then later, it's about the CFM per square feet value will be directly taken from the same Excel sheet itself. Okay, now by dividing the total CFM of that specific machine and the total area right inside Excel sheet that you've been taken out from the CAD drawing itself. All right. So this is the typical approach of Excel-based calculations. So is the designing is clear? Hello? Okay. Good to go, guys. What about 11th? Suppose if you're having values, you can choose here. Actually, this is the final step. Okay, now then this is just a symbolization. For multiple purposes, you having different variety of machines. I told you in the machine study itself, your companies will be having some kind of catalogs, machine catalogs, isn't it? So that's not a problem though. Then for higher tonnages, you might need to adapt some kind of different technologies that I will, different approaches. So that I will be explaining on the ducting side. You don't need to concern about right now itself. Just find out the actual tonnage required for the project. Okay, clear? Okay now. Is it clear, guys? Okay. So now we are going to say goodbye to this Excel sheet. Okay, now. Why? Because now from here onwards, we'll be jumping over to a next topic, which is named as to be HAP. Okay. So typically or technically, the concept of HAP. First of all, HAP is meant to be a software which you can do the heat load analysis in a software based approach. All right. Then HAP is Pardon? HAP is a software which is provided by the carrier itself. You know the carrier, isn't it? Carrier, which is the air conditioning company, isn't it? So HAP is provided by or developed by this carrier engineers or carrier software engineers something. So this while analyzing heat load calculation, especially in HAP, you will be getting a more precise values. So in this Excel sheet and manual calculation, it should be a per day concept itself, isn't it? It should be a per day concept, which is meant to be, can see this now, time of peak load. We will be considering the peak months, peak day temperature. So that's how you are calculating this manual and Excel based calculation, especially on this Excel sheet or paper, whatever. So in here, actually, we are oversizing the mission. But whereas in the case of HAP-based calculation, it would be more specific. That means that's why it is called as to be hourly analysis program. Okay, what is it? Hourly analysis program. So especially if you're working in some kind of MNC companies, mostly in Middle Eastern regions, they will demand the heat out calculations, especially in an app output itself. So you might need to know how to operate or how to do the calculation right inside the app software. Clear? So let's get started. So once again, HAP software is a very important topic among the heat load analysis. Then you can use an Excel sheet in order to support the HAP software, which means, in order to enter those values, you can use an Excel sheet to do that stuff. Clear? Okay. Otherwise, we can directly take out the values from this CAD drawings itself. So once again, guys, while doing HAP based heat out calculation, you still need a CAD drawing. Okay. Instead of using an Excel sheet, we are directly entering the values into a software. That is the only difference between Excel sheet and HAP software. Okay. Clear? So HAP is dedicated to do heat load calculations, especially for the HVAC industry. But Excel sheet, who can use the software? That's the difference. And once again, HAP, by using HAP software, peculiarly, you will be giving more preference to some kind of factors, especially the schedules that we can learn later. So now I'm going to open the CAD drawings for that one itself. Now we can see this is a project. Yeah. Mhm. You can see this now. Actually, this is a project called as to be theorem. Theorem project. Actually, theorem is doesn't means to be nothing. It's simply a company, sorry, a small commercial name. Commercial name. I hope theorem is a company name. Okay, that means given to some kind of pardon. We just done this project in Bangalore itself. Theorem project. You can see the data provided by the client. work on heat load calculation. You can see right at itself. ODC, again, Bangalore. Then IDC and RH is still same, which is meant to be the comfort temperatures and comfort RH. And bottom of slab, which is the height of the floor is 12 feet and bottom of beam is 10 feet, 10.5 feet and false ceiling is 8.5 feet. And after that, you can see consider 1 ACPH fresh air. And for a single person, the fresh air quantity is around like 15 CFM. Then the floor name is ground floor and no floor below, which means the floor load is again 0. Then floor above first floor, which is an AC space. So we don't need to consider the floor load or neither the ceiling load. Clear? Then for each system, the dissipation is around like 200 watts. Then once again, the client is devising it has to be consider conference room separate AC. That means we don't need to consider the conference room right inside our area. Instead of that, it should be maintained. It has to be a separate area itself. Why? Because the conference room should be operating only at the discussion times, isn't it? Other times it should be act as like a non-AC room, isn't it? So that's why the client is already provided it has to be consider conference room has to be a separate AC itself. Okay. Then the other data is given for the that means once again, guys, here we don't need to include the conference room, but they don't explain like it this way. For example, don't do heat load calculation for a conference room. Not like that. They're actually portraying that you don't need to include the conference room in your air conditioning area, but you need to still do the heat load analysis for conference room separately. All right. Then it's about the lighting load. It's around like 1 watt per square feet, and they are using fluorescent lamps. Then consider window heights. So inside the drawing, they having some kind of windows and the window height is possibly 4.5 feet. And they having also some kind of printer and the printer dissipation is around like 100 watts. Sorry, 1000 watts or 1 kilowatt. Then pantry and toilets should be considered as to be an exhaust system. All right. So this is it. So this is the data provided by the client itself. Now you can see right here itself. This one, especially this one, this area, we can see this now. This is the reception area and this is the waiting area. That means to be this is the entry. You can see the puja place and reception area. And similarly, the waiting area, then discussion room, utility room. And this is the workstation or the office cabins. Later, you can see the chairman cabin and the manager cabin 1, 2, 3. So 3 number of manager cabins. So technically here, we need to consider only this much space. Then here you can see this is the conference room with a pantry and an executive toilet. And this is the lift lobby. And here on the back side of this lift lobby, you can see your ladies' toilet and gents' toilet with a pantry right there itself. So this is the typical arrangement or a top view of a single floor, which is meant to be a theorem. Let's analyze the CAD drawing. So initially, I told you whenever you got a drawing, just check the primary units. So while I'm going with the primary units, we can use units command, which is UN. Okay. So after entering the units, here you can see this drawing is enabled in decimal or in millimeters, isn't it? Decimal, millimeters. That means the entire things are mentioned in millimeters only. But for our heat load analysis, I told you we will be more specifically for our ease purpose, we will be using some kind of, which means, in feet and inches, isn't it? So that means that we need to specifically use some kind of, we need to convert this millimeter value into feet and inches. Clear? So that's how we need to do the steps. So initially, we got the actual unit set it for this work plane right here itself. Later, it's about the area. So here I already considered the area or drawn the area. You can see this now, excluding this lift lobby and this conference room. I considered this area right here itself with the help of this move command. We can see this now. This is the area of this, or this is the actual area to be air conditioned by excluding the unwanted areas. Once you got this area, simply provide the command called list. Okay. Now you can see the area. So here the area is mentioned not in feet or inches. Instead of that, it should be mentioned in square millimeters. So just select this value, then Control C, which is copy, then use the help of cal enter. Not calendar, it's cal, C-A-L, cal C. Okay, cal enter. Click onto this command box and paste the value. And after that, we need to convert the square millimeter value into square feet, isn't it? For that one, I can use 1.0785 into 10 raised to minus 5. Okay, so this is the equation to convert the value into square feet. So the area of that space or the area of this space should be around like 2,203 square feet right there. Okay, so 2,203 square feet should be the area of this specific polyline that we've been covered right inside here itself. Okay, so is this clear? Hello, is it clear, guys? Hello, is it clear? Hello, yeah. So guys, can I ask you one thing? Yeah, go
Just a
on.
quick question. Can you just let me know how the area is calculated? Like,
Okay, fine. I will
the
do it.
portion was selected, right?
Yeah. Okay. I will do it. Okay, so let's guys, so how to select the area, isn't it? Yesterday I told you that you can use either area command or polyline command. So here I'm using this polyline command and you can see a small yellow line is following me, isn't it? Then just cover up the internal areas like this way. Okay, now just cover up the internal wall areas like this way. Then after that, you can see likewise. So you might have the idea to exclude the other unwanted areas. Okay, then only you can choose it properly. Otherwise, it should be in vain. Okay, so you also have an idea where I need to consider the air conditioning or the air conditioning area and which cells I need to exclude. So that is it, guys. Actually, I'm excluding this lift lobby, pantry, and this toilet, and also this conference room connected with this executive toilet and pantry. So with excluding those all areas, and I'm ending up with the same starting point itself, isn't it? So this is how you need to take out the area consideration. Okay, clear? Clear, mice? Clear now?
Please.
Okay, fine. So today I might need to start a HAP software because it takes more time. So from tomorrow onwards, it should be leave probably, Deepavali leave. So or I will inform you guys. So actually do one thing. I will share this some 7 projects. Okay. So along with that 7 project, you'll be having some kind of Excel sheets also. So just go through that Excel sheets. Pardon. Just do the heat load analysis right with the help of this Excel sheet. So can you do that for me? Hello.
Yes, sir.
ഓക്കെ അല്ല ഞാൻ പറഞ്ഞ മനസ്സിലായോ അപ്പം ഇന്ന് ഹാപ്പ് എടുത്തു കഴിഞ്ഞാൽ എന്തായാലും തീരത്തില്ല വിച്ച് മീൻസ് ഇറ്റ്സ് എ ബിറ്റ് ലാർജ് ടോപ്പിക് യു നീഡ് ടു ക്ലിയർ മോർ തിങ്സ് ഇപ്പൊ ഞാനത് പാതിക്ക് വെച്ച് നിർത്തി കഴിഞ്ഞാൽ നിങ്ങൾക്ക് ആ കണ്ടിന്യൂറ്റി പോകും അതുകൊണ്ടാണ് ഞാൻ പറയുന്നത് എന്താ ചെയ്യണ്ടേ നമുക്ക് നെക്സ്റ്റ് സെഷൻ ഫ്രഷ് ആയിട്ട് എടുത്താൽ പോരെ ഹാപ്പ് അത് തന്നെ ഇപ്പൊ തന്നെ സ്റ്റാർട്ട് ചെയ്യണം അതുകൊണ്ട് ബാക്കിയുള്ളവർക്ക് എങ്ങനെയാ ലൈക്ക് ഫോർ അതേഴ്സ് ഐ ക്ലിയർ like HAP is a bit large topic, so we need more time to get onto that thing itself. So just go through this class once again and do the heat load analysis, especially for the other projects that I will be shared through the WhatsApp itself. Okay, now so you can work on to this weekends, and after that we will be starting over with the HAP and then to the AutoCAD software. Okay, now clear?
Please.
Okay, Nane. Okay, Nane.
HAP software ലിങ്ക് ഒന്ന് അയക്കാമോ? അങ്ങനെയാണെങ്കിൽ ഡൗൺലോഡ് ചെയ്ത് വെക്കാം.
ഞാൻ അയച്ചിടാം. ഓക്കെ എന്താ പറ്റി? ഞാനത് അയച്ചിടാം. ഞാൻ വാട്സപ്പിൽ തന്നെ അയച്ചിടാം നിങ്ങൾക്ക്. ഞാനത് വാട്സപ്പിലല്ല, സോറി, ഒരു ലിങ്ക് ആയിട്ട് അയച്ചിടാം. കാരണം 500 MB മുകളിലുണ്ട്. ഒരു ബുക്കാണ് ആക്ച്വലി. ഓക്കെ, സോ ഐ വിൽ ഷെയർ ദാറ്റ് ത്രൂ യുവർ വാട്സപ്പ് ഇറ്റ്സെൽഫ്. ഓക്കെ, സോ വൺസ് അഗൈൻ ഗൈസ്, അപ്പം ഈ ഒരു വീക്കെൻഡ് നിങ്ങൾ നന്നായിട്ട് യൂസ് ചെയ്യണേ. കാരണം ഞാൻ ഒരു 7 പ്രോജക്റ്റ് എടുത്ത് ഞാൻ കംപ്രസ് ചെയ്ത് അയച്ചിടാം. ഓക്കെ, ഒരു CAD drawings ആണ്. You can use the same Excel sheet, yeah. Okay, you can use the same Excel sheet for them. That means I already shared to your WhatsApp group now. You can use the same Excel sheet, but the CAD drawing should be different. So once again, I need to show one more thing. You can see on this theorem project, actually, while doing this theorem project, you might need to create something like this way. You can see this now. Wall plus NOR, especially you need to create something like this and just make your, it has to be all borders. For example, in here, actually the wall areas should be find out from the CAD drawing itself, isn't it? So this is the whole area on the northern side. Why? Because on the bottom side, you can see it's now upside is north. So in generally, while you are using this dimension linear command, what will happen? We can directly take this from this point to this point. But the problem is not this. Actually, while doing that step, your values should be in feet, pardon, in millimeter, isn't it? So in every time we need to convert the value from millimeter to feet, again millimeter to feet. So it's a bit hard to do and it will consume more time, isn't it? So instead of doing that stuff, just enter D. D means dim style editor. Okay, dimension style editor. Go on to this dim style editor and click on to this modify. You can see something like this. Primary units. So here you can see, I told you, you don't intended to change the primary units. Instead of that, near to that primary units, you can see alternate units. Then here I already entered this one. So if in your laptops, maybe it should be something like in disabled portion, disabled, just click on to this display alternate units and make it as to be architectural. Okay, make it as to be architectural. Then if you need precision, make it as to be 0 feet 0 inches. Then the value should be directly converted into, for example, it's like 11 feet 5 inches. Okay, so that should be more specific for you to enter the value right inside your Excel sheets. Okay, now then after that, click OK. Then make it as to be set current. Then close it down. Now, if you use this dimension linear command, you can see among this, along with this millimeter, you will be getting the equivalent feet value of this length right here itself. Clear? Okay, now. So for example, here you can see the total wall length is 38.2 in 2 feet. Okay, 38.2 feet. So here, this is meant to be wall plus glass area. You can see this is the individual glasses. Pardon, the windows I'm saying. So here I'm taking out the value for this windows. It's like 7 feet 10 inches, isn't it? So I know that the entire window is 7 feet 10 inches. That's why I'm not measuring here. You can see this now. In this northern side, mostly the windows are in same size itself. It's all having 7 feet 10 inches. So technically 3 number of windows. So in the first step, you need to include or you need to find out the value like this way. 38.4 or 38.2 into BOS, which is meant to be this 12. Then you'll be getting a total wall plus glass area around like 458.4, isn't it? Now it's turned about the glass. So total, pardon, the length of the glass is 7 feet 10 inches, which is 7.8, isn't it? Then what is the height of the glass? Inside the CAD drawing data, they already provided. Consider window height 4.5 feet, isn't it? So multiply the value with 4.5. Then how much number of windows are there? 3 number of windows. So just multiply the value with 3. Then you'll be getting 105. Then at the last step, you need to find out the actual wall length, wall area. In the first step, you got the wall plus glass area. That doesn't mean to be the wall area, isn't it? So in order to get the wall area, just minus this value from this glass. Okay. You will be getting 353.1. Now it's very simple. You just need to select the cell and put equals and click this one. Especially do the same for glass. Just select this one and select this glass. Okay now. So that's how you need to update your values right inside the Excel sheet. Clear? It's been more specific. If someone is including into your Excel sheets, then they can analyze it very simply. Okay, what in northern side, this much is the glass area and this much is the wall area. Okay now, clear? Clear, guys? So two important things that I told right now itself. First of all, it's about the dimension style editor, which will enhances the, the alternate units. So it should be more specific for you to calculate and you don't need to waste your time to convert the value from millimeter to feet in every time. Instead of that, just enable this alternate units. And after that, just create a column for both wall plus glass and wall. Then you'll be getting the values much more specifically. Clear? So do the same thing for the upcoming projects also. Okay, now clear? Manslayo. Clear, guys? Hello, Shanmugaman. Okay, all good. Okay, Manu. Okay, fine. Okay, guys. So I hope it's I will be share this CAD drawings to your respective WhatsApp itself. then go around this CAD drawing. If you're having any doubts, just let me know in the WhatsApp itself. Okay, now not a problem to disturb me. So just go on. If anytime you can contact me. Okay. So I think we can wind up our session for today. So have a great day, guys, and happy Deepavali. Okay, we can leave, guys.